Okay, so we're going to look at some arithmetic and geometric sequences. So the directions have three parts here. The first question says to state whether the sequence is arithmetic, geometric, or neither. We're going to justify that. And then if it's either arithmetic or geometric, then we want to predict the next two terms. So really, if we say that it's neither type of sequence that we're studying, we can just stop there. We don't need to continue the question. Okay? So number one, we have talked about the only way that we can go from positive to negative to positive to negative is if it's a geometric sequence multiplying by a negative number. So to check that out, if we took negative 500 divided by 100, we get negative 5. If we then try 100 divided by negative 20, we also get negative 5. So it's looking like, yes, this is a geometric sequence. It's multiplying by negative 5. Okay, so we would say geometric. Our justification is that there's a common ratio, which is negative 5. Okay, and then to continue the pattern, to predict the next two, negative 500 times negative 5 would give us positive 2,500. And then multiplying that by negative 5 would go back to a negative value, negative 12,500. Okay. Number two, when I look at this one, I see it go up 2, then up 3, then up 4. So right away, we know that this is neither type of sequence we studied, because there is a pattern there. We can see the pattern, but it is not a common difference or a common ratio. The pattern is changing as we go. The pattern went +2, then +3, then +4, so it changed. All right, number 3, we're going from 64 down to 48 and then down to 36. Well, for a pattern to decrease, it either has to be an arithmetic sequence with a negative common difference, or it needs to be a geometric that is multiplying by a fraction or decimal smaller than 1. So if we look here, if we tried 27 minus 36 from the back in reverse, 27 minus 36 is negative 9. Then 36 minus 48 is negative 12. That means there's no way it's arithmetic. Okay? So then we would try to see if it's geometric. 27 divided by 36 is 3/4. 36 divided by 48 is 3/4. And 48 divided by 64 is 3/4. So yes, this one is geometric. We know that because it has a common ratio of 3/4 or 0.75. So to continue that pattern and supply the next two values in the sequence, we want to do 27 times 0.75, which would be 20.25. And then that value times 0.75 or times 3/4 is 15.1875. Okay, number 4. This one is decreasing, so I can see from 1.5 down to 0.75. That takes half of the that is half of the value. But half of 0.75 is definitely not 0. So it's not going to be geometric. Let's check and see if it's arithmetic. So if we start from the back, negative 0.75 minus 0 is negative 0.75, 75/100. 0 minus 75/100 is negative 75/100. And 75/100 minus 1.5 is negative 75/100. So we have decided that this is arithmetic. We know that because there is a common difference, or constant difference if you prefer, which is negative 75/100ths. So to continue this pattern, the next two, we subtract that from negative 75/100ths, we get negative 1.5. One more time, we get negative 2 25/100ths. Okay, number 5. Again, we have a pattern where the numbers are decreasing. So could it be subtracting? Could it be arithmetic? Well, if we look from 40 down to 10, you would have to subtract 30. That certainly does not happen going from 10 to 5 halves. So let's try geometric. Now, what we would be doing is 5/8, we start from the back, and divide by the previous term, 5 halves. Well, what that really means, the way you divide fractions is 5/8 times the reciprocal 2/5, and that is 1/4, or 25/100ths. If we try that again, 5 halves divided by 10, that would become 5 halves times, now since this was 10 over 1, the reciprocal is 1/10. So that's 5 over 20, again, 1/4. And 10 divided by 40 is, once again, 1/4. So we do have here a geometric sequence. And we know that because it has a common ratio of 1/4. Okay. If we continue that, we're going to take the 5/8 times 1/4. So let me go over here on the side. 5/8 times 1/4, that's 5 over 32. We can't simplify that. We certainly don't want to try to make it a decimal. So 5 32nds. And then that number times 1/4 again would give me 5 over 128, which again does not simplify. Okay, and number 6, it's increasing, but from 1 to 11 goes up 10. From 11 to 1,111 goes up 1,100. So definitely not arithmetic. To check geometric, 11,111 divided by 1,111. Oops. Would be approximately 10.0. Now, 1,111 divided by 11 is 101. So that one indicates that it's definitely not geometric. So it's neither one of the sequences we have studied. Now, is there a pattern here? Yes, in some way, it looks like first we added 1 0, and then, or, I'm sorry, 1 1, and then we added 2 1s. So we added 1, next time we added 2, the next time we added 1. So it looks like we could explain and identify and continue a pattern here, but we don't actually need to do that part of the question. Once we say there's neither, and it's because there's no common difference and there's no common ratio. Okay. Number 7. We have all negative values. They are decreasing. So let's check to see if it's arithmetic. Negative 12.15 minus negative 8.1 is negative 4.05. Negative 8.1 minus negative 5.4 is negative 2.7, so not arithmetic. Okay, then let's check to see if it's geometric. Negative 12, 15, and we would divide that by negative 8.1, and that's 1.5. Negative 8.1 divided by negative 5.4 is also 1.5. Negative 5.4 divided by negative 3.6 is once again 1.5. So this tells me we're looking at a geometric sequence, and we know that because it has a common ratio of 1.5. So if we were to continue this, negative 12 and 1500ths times 1.5 becomes negative 18.225. And one more time, take that value times 1.5. We have negative 27.3375. Okay, number 8. This one, they are all negative so far, but the values are increasing. If we look, how far is it from negative 64 up to negative 47? Well, that adds 17. From negative 47 to negative 30, add 17. Add 17. So we here see an arithmetic sequence because it has a common difference of 17. So if we continue that for two more places, negative 13 plus 17 is 4, and 4 plus 17 is 21. Last one on the front side here, we are to create for ourselves a sequence, one that we could explain, we could predict new values, but not arithmetic or geometric. Now my favorite one like this is called the Fibonacci sequence, which goes 1, 1, 2, 3, 5, 8, 13, and continues infinitely. And the pattern that we have in this sequence is we start with two ones, and then each successive term just adds the two previous terms. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, but it is not, however, arithmetic or geometric. All right, on the back side, we're going to look at some situations and decide whether we believe them to be discrete or continuous relationships, okay? It doesn't say we need to explain. Of course, you should do that, at least in your head, if you don't write it down, and be ready to explain that if you were asked. So number 10, the hair on your head grows a ½ inch per month. Well, to be discrete, that would have to mean that it actually grows 1/2 inch exactly each month, and it jumps. It grows that 1/2 inch all at once. For example, you go to bed on May 29th, when you wake up on May 30th, your hair is a ½ inch longer. That is not the case. It grows at a continuous rate throughout the month. The 1/2 is just an average. So this is a continuous relationship. Number 11, for every ton of paper that is recycled, 17 trees are saved. Well, is paper recycled exactly 1 ton at a time, and it saves exactly 17 trees for each ton? Okay, does that mean if we tried to recycle a ½ ton of paper, we could not save 8.5 trees? Again, this is not something that jumps 1 ton at a time or 17 trees at a time. So this is continuous. Number 12, approximately 3.24 billion gallons of water flow over Niagara Falls daily. Any type of waterfall could certainly not be counted in gallons or any other measurement in a discrete manner. So this one is definitely probably the most obvious one on the paper. It is continuous. And last one we're looking at, or I'm sorry, two more. the average person laughs 15 times per day. Now, that does not mean that we would have to be counting by 15. If you would say, no, yesterday I only laughed 14 times, that does not mean it can't be discrete. When you count your number of laughs, it would count by ones. You're not going to laugh 14.1, 14.2, 14 and 3/10 times per day. So you laugh once or twice or 3 times or 4 times. So that is an example of a discrete relationship. The city of Buenos Aires adds 6,000 tons of trash to its landfills every day. Very similar to the waterfall problem, you could not possibly count every little tiny bit of trash added to a landfill. It could be measured in any type of decimals, fractions, anything from 0 and above could be an amount of trash that you add to a landfill. So this would be, once again, continuous.